Hi, this is Rob Yates, and welcome to Lesson 11 in Week 4 of Algebra 1 Distance Learning. If your teacher is Ms. Boatwright, Ms. Reynolds, Mr. McRae, Mr. Strickland, Mr. Still, or Mr. Yates, you are in the right place. I want to remind you that you can stop the video at any time and rewind it, or fast forward it, or play it all the way through to the end and then play it again. If you get to the end, however, you get to the joke of the day. Today's learning target is I can find the roots of a quadratic equation using the zero product property. The zero product property. If A equals 0, A times B equals 0, then either A has to equal 0 or B has to equal 0, or possibly both A and B are 0. We use the zero product property to find the roots of an equation when it's in its factored form. Basically what they're saying is if you multiply two factors together to equal 0, at least one of those factors needs to be a 0. 0 times anything is 0. And so we factor the same, but now we're using this factoring to solve an equation. Our steps are, we factor first, then we set each factor to equal to 0, and then we solve both equations. Well, if you're a little worried that you don't quite follow that, don't worry. We're going to go over here for you in this example. Here's our standard form. X squared minus 2x minus 5. The factored form is x minus 5 times x plus 3. We know that because, of course, A is 1 and C is negative 15, and A times C is negative 15. B is negative 2, and negative 5 times 3 is negative 15, and it also equals negative 2. So, negative 5 is one of our factors, and 3 is one of our factors. X minus 5 times x plus 3. Why is that important? Because we can determine what the roots are by making them equal to 0, like this. X minus 5 equals 0. Now I know how you do that. You got to get all your numbers on one side and all your letters on the other, so I got to get rid of this negative 5. The opposite of negative 5 is plus 5. It's okay that I do that as long as I do it to both sides of the equal sign. I bring down my x. X minus 5 plus 5 is 0. 0 plus 5 is 5, so one of our solutions is 5. For the other one, we have to write down x plus 3 equals 0. Again, got to get all my letters on one side and all my numbers on the other, so I do the opposite of plus 3. I go minus 3, and that's okay as long as I do it to both sides of the equal sign. 3 minus 3 is 0. I bring down my x. 0 minus 3 is negative 3. So, we have, through the zero product property, discovered the roots of the equation. These are the roots where it crosses the x-axis. Let's take a look at some more examples. X squared plus 5x plus 6 is our first. To find the roots, we have to factor it. So, we need to know A is 1, C is 6, so 1 times 6 is 6, B is 5. What two numbers multiplied together equal 6 and added together equal 5? Well, I'll let you think about that, but if you guessed 2 and 3, you are correct. 2 times 3 is 6, and 2 plus 3 is 5. So, x plus 2 equals 0. X plus 3 equals 0. To solve the first, I would subtract 2 from each side. That goes away, and what I'm left with is x equals negative 2. The second is similar. Minus 3 minus 3. X equals negative 3. So, my roots in this case are negative 2 and negative 3. How about our next example? What we've got over here is 1 times 12 is 12, and negative 8 is our answer over here. Now, the only way we can come up with a positive product and a negative sum is if both of them are negative. So, how about negative 2 times negative 6? That equals positive 12, and it adds up to 2. So, I would have x minus 2 equals 0, and x minus 6 equals 0. Then I solve them the way we've been doing it since the beginning of the year. Letters on one side, numbers on the other. To get rid of a negative 2, I do the opposite, which is plus 2. And I end up with x equals 2. How about this one over here? I have x minus 6. What should I do? Think about it. Stop the video if you have to. And tell me. Hopefully you stopped the video and you thought about it and you said to yourself, to get rid of this, I have to add 6. Which means, since negative 6 plus 6 is 0, x equals 6. These are my roots, 2 and 6. All right, let's take a look at this last one over here. This is interesting because it's a perfect square. Do you remember our steps to solving a perfect square? When it's the difference of a perfect square, we take the square root of x squared, which we know to be x, and we take the square root of 25, which we know to be 5. And we make one x plus 5, and we make one x minus 5. These are our roots. We have to make them equal to 0 to solve. So, x plus 5 equals 0. X minus 5 equals 0. How do I solve this? Well, x plus 5 equals 0. I subtract my 5 from each side, and I get x equals negative 5. On the other side, since it's a minus 5, I add 5. And my answer then becomes x equals 5. Negative 5 and positive 5 are my roots. In summary, today we learned what it is called, the zero product property. We use it when a quadratic equation is equal to 0. First, we factor. Then we split the factors into two different equations that are both equal to the ever-popular 0, and then we solve them. And when we solve them, we come up with our roots. What can you do next? You can log into Khan Academy, or you can log into student.desmos.com. You can try Worksheet 11, Google 11, or go on and watch Video 11. Today, our joke of the day starts out, what did the grape say when he was pinched? Nothing. He gave a little wine. Thanks again, and we'll see you next time.